Unit 8 is about scaled figures / dilations. We've already seen that a dilation can either shrink or enlarge something depending on what the scale factor is. Now we're just putting it into action with actually transforming these shapes. And so number 1 is really easy. It says plot the image of figure ABCD, this rectangle, after a dilation with a scale factor of 3. One of the sides has been plotted for you. So basically saying that when the scale factor is bigger than 1, it's getting bigger. And so we're just taking each length and multiplying by 3. And so they've already done this one for us. We won't worry about it. But if I count up from C to D, that's 1, 2, 3, 4 boxes. I would want to take 4 times 3, so that's 12. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. That puts us up there. This one's easy because then I can obviously see how to finish it out. So on Delta Math, you'll just click one point and you'll drag it to another one to make a segment. Number 2 is more of a pain in the butt than anything because we have this very weird shape. It's called ABCDEFGH after a dilation with a scale factor of 1/3. So 1/3 is smaller than 1. That means that our shape is going to shrink by dividing each length by 3. And they've already done EF for us, so we won't worry about it, but let's go F to G. That's 1, 2, 3, 4, 5, 6, 7, 8. That's 9. So think of 1/3 of 9 is the same thing as 9 divided by 3, which is 3. So I would go 1, 2, 3 boxes here. And then let's go 1, 2, 3, 4, 5, 6, 7, 8. That's 9 as well. So again, 1/3 of 9 would be down 1, 2, 3. And then H to A is 12. So 1/3 of 12 or 12 divided by 3 would be 4. So you can go ahead and finish your shape out, see if you can get it to look the same. And that's what it should look like. So once you get to a certain spot, you don't have to count anymore. You can just finish your shape. It's so cute. All right, and then number 3, there's 2 different ways you can think about this one. We are having slanted lines now. It makes it a little more complicated. Our scale factor is 3/2, which is actually bigger than 1. That's 1.5. And I use this a lot when I'm making recipes of something. I know I don't want to double it because it's too much. So I take 1 of that and then I add half of that whole to it to make it a little bit bigger. So we've got KL already done for us. Won't worry about that one. Let's do KN. So what you could do is think slope. Rise over run means like a vertical movement before a horizontal movement. From K to get to N, I would go up 1, 2, 3, 4, 5, 6, and write 1, 2, 3, 4. Going up is a positive, going right's a positive, but I want to take 3/2 of both of those numbers. So 3/2 of 6, I'm going to divide first. 6 divided by 2, or take out a 2, that would be a 3, and 3 times 3 is 9. So I want to go up 9 units. And then let's do that for 4. 3/2 of 4. I can do 4 divided by 2. And 2 times 3 is 6. Saying it's 1/2 of 4 plus half of 4, which is 2. 4 plus 2 would make 6. So I want to actually go up 9. 2, 3, 4, 5, 6, 7, 8, 9. And write 1, 2, 3, 4, 5, 6. Almost need a ruler, but again on Delta Math you'll just click and drag. Okay, N to M is easy because it's just a horizontal line. 1, 2, 3, 4. You'll take 3/2 of 4, which we said is 6. So go 1, 2, 3, 4, 5, 6. And I want to show you one other thing that I kind of like to do. So if I didn't know L to M, I could count slope. So from L to another point I see is here, 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 here. It goes up 1 box, right 2, or backwards, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. It took me 1, 2, 3, 4 times of that pattern. And so I could think what's 3/2 of 4 is 6. So I would make 6 of those up 2, right 1. There's 1, 2, 3, 4, 5, 6. So up to you, but that's another option, is figure out how many patterns of slope and then do that scale factor of it and then make that many more patterns.